Hey guys, so today I'm going to talk about the topic applications of mathematics, and I specifically chose the topic logarithmic functions. So to talk about the uses of logarithmic functions, we first need to know what are logarithmic functions. A logarithmic function is the inverse of an exponential function. Here's the example of an exponential function. 2 to the power of 5 is equal to 32. 5 is the exponent of 2 here, and it represents how many times we need to multiply 2 to get the value 32. So what if the exponent isn't given and we want to find out how many times we need to multiply 2 to get 32? We can find it out by using this way. And from this method, we now know that we need to multiply 2 5 times to get the number 32. But what if the number we want to get is so high instead of 32? What if it is like hundreds of thousands or millions? That's where logarithmic functions come in. Here, log base 2 of 32 is equal to 5. And this base 2 represents the number we're multiplying. And 32 is the number we want to get. So log of 32 base 2, the answer of it will be 5. And it's 5 represents the exponent from the exponential function. It's the amount of 2's we need to multiply to get the number 32. So that's what a logarithmic function is and how it is the inverse of an exponential function. So today I'm going to be talking about two applications of logarithmic functions in real life. One is applied in chemistry and it's used in the pH scale, and the other application of logarithmic function is in physics while calculating the intensity of the sounds, the decibel scale. So the pH scale in chemistry. So first of all, what is pH? What is pH? So pH is a measure of hydrogen ion concentrations of a solution, and the pH of that solution tells us how acidic or alkaline the solution is. And the pH scale ranges from 0 to 14. 0 to 6 being acidic, 7 being neutral, and 8 to 14 being alkaline. A solution with a pH of 1 is extremely acidic, while the solutions with a pH of 14 are very alkaline. So here are the examples of solutions and substances with different pH in our daily lives. So, how is logarithm connected to the pH scale? Well, the equation used to find out the pH scale has logarithm in itself. Here's the equation. pH is equal to negative log of H plus ions to the base of 10. Here's a little history lesson. This equation was first proposed by a Danish biochemist Søren Peter Lauritz Sørensen in 1909. And by using this equation, we can find out the concentration of H plus ions in a particular solution. For example, here are walked examples of how the concentration of H plus ions are found. So for example, a solution with a pH of 1 will be equal to negative log of H plus ions to the base 10, and then if we work it out, we'll find to a conclusion and the answer that the concentration of H plus ions in this solution is 10 to the power negative 1 mole per liter. And in here, the solution with a pH of 13 has a concentration of 10 to the power negative 13 mole per liter. So this is the use of logarithm in finding out the concentration of hydrogen ions in solutions and working out the pH of a solution. So now the application of logarithmic functions in the decibel scale. So what is the decibel scale? It is a measure of how intense or loud the sound is, how powerful the sound is. And the formula for calculating the decibel of a sound includes logarithm, and here's the formula. So the decibel of the sound is equal to 10 multiplied log p over p0 to the base 10. So first of all, what does p and p0 mean? Well, P0 represents the weakest sound our human ears can detect, and that weakest sound has the power of 10 to the power negative 12 watts per square meter. And P represents the sound being detected by our ears right now, the power of the sound being detected by our ears right now. And our ears can detect up to the sounds with the power of 10 watts per square meter. So if you look at this, our ears can detect sounds with powers ranging from 10 to the power negative 12 to 10 watts per square meter. It's an enormous range. So first, here's the decibel scale of the daily sounds we hear. So the sound with the decibel 0 is the weakest, softest sound our ears can detect, which means it has the power of 10 to the power negative 12 watts per meter square. And the largest decibel scale represents the sound with the largest power, which is 10 watts per square meter. So again, here are the daily sounds and noises we hear every day and how loud they are, how powerful they are, and they're represented in the decibel scale. So what if the decibel scale formula doesn't have a logarithm in it? It will just be P over P0, and if we want to find the decibel of a normal conversation noise, the intensity of a normal conversation noise is 10 to the power negative 6 watts per meter square, and so it will be represented by P, and P0 will be 10 to the power negative 12 always. So if we don't have logarithm in the formula, the answer will be 1 million decibel. That's a lot, and we haven't even multiplied 10 into it. So without the logarithm, the scale will be very large, and it will be very large for us to comprehend. So that's why we use logarithm in the formula, and that's why the decibel scale is a logarithmic. That's why the decibel scale is a logarithmic scale. So thank you, and that's it for today.